All right, what is up, Moneysocket? T.me, Moneysocket. Join there if you want to discuss or criticize or give feedback, or if you want to record a video and post it, I can add it to the playlist, that kind of thing. So today I'm going to show some code running that I haven't shown before. I've been working hard on it, doing a lot of the boring details, but I've got something sort of set up that's a little less boring, so I'm going to show that off. So these terminals are set up deliberately in this order because they correspond to what's on the diagram. So I'm going to explain that. But yeah, the junction, junction, terminus, terminus, relay, and then the browser. So to just explain this setup, I'm just going to go refer to this diagram first before I actually run the code. So the terminuses are like the full wallet implementation. So they're what's deeply coupled to the actual node, so it can actually generate valid bolt 11s and pay bolt 11s, and reliably report when things have actually been paid. So that's what I'm calling a terminus. And I'm sort of adopting the terminology of a circuit. If you got different thoughts on what the terminology should be, certainly chime in and let me know. But I've got terminuses, junctions, and relays as sort of the jargon that I've introduced here. So I think, yeah, terminuses are pretty straightforward, and these implement wallets. But junction is a little bit, I guess, a little less clear just from the name. But I'm thinking about sort of these advanced apps where we're talking like the streaming use case we've talked about, where there's one piece of software that's managing lots of connections to wallets and services and all that. So out of many connections, it's there then to hold the logic of like how to route things or how to accept or reject things that are passing by. So it's sort of this in-between thing that has multiple entrances and exits and logic that you might want to include. And then likewise, so if you just take this picture and then just expand what like a streaming service might be, an implementation, it's sort of, yeah, you have a streaming service and then lots of customers are connected, and then you have your backend wallet. So that's maybe another example of a junction. And then also for like the fiat custodial model, this junction here, there might be like you likely have like a fiat custodial layer on top of the actual Lightning Satoshi layer. So if there's a customer balance that says, oh, this customer has $10 in fiat, this wallet is going to report that fiat balance and be dynamic according to what the price feed calculates. Whereas the actual underlying wallet that's tied to the node, this is going to work purely in Satoshi. So this junction application is going to go implement whatever custom logic that service needs to have. So that's the idea there. And then relay. We've discussed the firewall issues. So this is to provide a proxy to get past the firewall from your browser to a wallet. All of these apps, Relay, Junction, and Terminus, they all are using a common Moneysocket library that I've implemented. So just briefly in the code. So there's this Moneysocket library which has the common code, and then the specific expressions, the junction, the relay, and the terminus are then the application. So in the Moneysocket library, there's the core, the lightning, the persistence, the socket, and then some common util code. Move that out of the way. So in a previous video, I explained kind of the architecture model, and that's what I'm trying to adhere to in the actual library. Split up the core from the socket, from the lightning, from the persistence, and then the junction, the terminus, and the relay, and then whatever insert your own app is then the application code. So I've spent a lot of effort kind of making the code base clean and adhere to this. And then it's an ongoing process as we're actually fleshing out what the actual in protocol messages are, what is going to be handled down here and what is going to be handled up here. And then also at the socket layer, so one thing when we're talking about the firewalls, the way the socket library I have, which I've actually implemented like this, there's the difference between a listening WebSockets, one that like listens on a port and waits for people to connect to it, and then the one that makes the outgoing connection. So I've abstracted all that away in this library, such that this layer up here doesn't have to worry about whether it's incoming or outgoing. So there is kind of this layered notion where in practice these guys can connect either way. They can either be set up as a listener or a connector. So on some deployments it makes sense to be a listener, and others it makes sense to be a deployer, a connector. So yeah, for example, the relay, because there's this firewall, we got to connect one way through the firewall to get to the relay, whereas connecting out might not be possible. So yeah, the library all handles all that. That's all details. So I'm actually gonna now go into the code. So I'll start up the terminuses first. So right here, this is C Lightning starting up the node software that's also running the terminus part of it, and it's listening on that port. And and then it also started a telnet CLI interface. So that's what these terminals behind are. So again, this is stuff that took a while to implement, but it's not necessarily necessary for the specific Moneysocket. This is just kind of infrastructure you take for granted. I have a CLI interface where you can configure up new wallets and program them to either listen or to connect. So that's driving all of this this low-level stuff here from the application. So yeah, it's important, but it's not. We don't have to discuss it specifically. But yeah, so I have a telnet interface. So these two guys are now listening for incoming connections. They have wallets. They're set up as listeners. So I'm going to start up this junction here first. And then likewise, it has a telnet interface. So it's set up to be a service, which is going to then connect to the wallet. So this guy was listening on 1158, and this 11058, and this guy's connected as a service to that on the port. But this guy's also listening. He's trying to connect to a 11057, and it can't find anything there because this guy is not listening. So yeah, over here it's trying to create this connection, but it can't because this guy's running. And this is a connector and this guy's a listener. I could have set it up the other way where this guy's a listener and this guy's a connector, but yeah, that just illustrates some of the WebSocket details we need to worry about. So I'm going to start this guy up so he's connected, and then right after it established, so there's a 10-second retry. So this guy that was unable to connect, if I ls again, he'll be connected. So he was able to make the outgoing connection. And you see this guy is now retrying. He's trying to find the relay. So he's configured up to be trying to connect out to a wallet, which is connect out to a service. So he's a wallet. He's trying to connect out to a service, which is the relay. And so he's just going to retry every 10 seconds. So when I start the relay starts up as a listener, and then this should succeed when the timeout triggers and he connects. Let's just give it a second. Yep, so it connected, it got the connection. And then, yeah, likewise, it also connected down here. So it was not connected, and now it is because the relay connected in. So here we have these all connected up to the relay. Now it's just missing the actual browser to join the party. So I have this instance so I can connect to the relay. So I've got a socket between that. Now, I haven't actually implemented any of the nitty-gritty of the protocol. I've just set up a basic ping pong. It's a lot of work doing the persistence and all that, so that's what took all the time. But now this is set up on a platform where we can start experimenting with the rules of Moneysocket and what messages are exchanged. But for now, for the purposes of this demo, I just have a ping pong setup. So I can send a ping message through the socket, and it'll get echoed through all the clients. So I can do it multiple times every time I click it. So I'll just refresh, I'll disconnect, I'll connect again. So what's happening when I send out a ping? So it's going to the relay sends it to the junction. Now the junction has two outgoing, it's got two services. So the way I implemented the junction is I just send the ping in both directions. So I get one ping request incoming, and I send out two as outgoing. So one that way and then one that way. And then, so yeah, this junction will similarly relay it to the terminus, and then the terminus catches the ping, and then it replies with a pong. So then likewise, the pong goes back up to the junctions. This junction receives 2 pongs, and it sends 2 pongs. Now I could have implemented that differently, but yeah, just for the purposes of demonstrating, when I send a ping, I actually get 2 pongs back because of that split, that the reply is a pong, and there's 2 of them, so the 2 get forwarded. If I were to kill this guy, so this guy's no longer running, so we're disconnected here. Disconnected. So here, if I send a ping, this path succeeds and this one errors because it can't actually forward that anywhere. So I get an error and a pong back. So that's just the basic example. So yeah, in the proof of concept, of course, I was passing around bolt 11s and paying them. That's the next step. But then yeah, questions of like how to do the protocol to this guy is not a quote unquote real wallet, and neither are the junctions. So then yeah, how do the rules play out according to how we define these apps and then the protocols. So yeah, if like for example this wallet, if it has a balance of 1,000 because there's a 1,000 balance, it's echoing the balance. This is a balance of 1,000. So then it's up to this app to then decide, okay, what balance am I reporting? If I have 2 wallets of 1,000, maybe I report that as 2,000, or under some sort of rule set that's up to this guy to decide. And then yeah, if there's a request to pay and then this guy like is not connected, it's waiting for a connection to come. What does this wallet do? How does it error out, or does it say, oh, hang on, we're waiting for the wallet to initialize or whatever as all of this gets connected? How do you define the protocol such that this service gets a nice clean experience in the protocol? And then yeah, there's common rules for the next wallet and the next app and the next in between middleware thing that comes along. Okay, that's 12 minutes, so I'll stop there. But yeah, talk to you in the Telegram, and peace.